Welcome to this presentation of the Class A reclaimed water through Low Ridge Technologies. We call this program the 2222 Oscar program, where we have 2 milligrams per liter BOD and TSS, less than 2, both on turbidity and total coliform. We do or have 4 steps within our technology train. Step 1 is settling. Step 2 is an oxidation step where we use a recirc tank and a low flow filter. Step 3 is filtration, where we dose the low flow effluent through an Oscar system, and then we polish off through UV light to end up with Class A reclaimed water. The system is comprised of basically 4 tanks or 4 types of tanks: a settling tank, a recirc tank, a clarifier, and then what we call a discharge tank, which doses to the Oscars themselves. The low flow is comprised of 3 main components: the coil of subsurface drip tubing. We use a specific media for the treatment media, and then a containment vessel or basin. The basin has really 2 options. One, we can use one large container to house multiple coils, or each coil could be housed in a polyethylene basin such as you see here. The media is actually a pumice stone made from recycled glass. How the flow of the low flow works is raw sewage will enter into the settling tank. It will displace an equal amount of water into the mixing or recirc tank. From the recirc tank, we also have liquid coming back from the low flow filter, and the system is designed to have at optimal about a 4-to-1 ratio. For each gallon of sewage coming into the recirc tank from the settling tank, that water will recirculate 4 times through the low flow filter. To get a concept of the quality of effluent that we're talking about, on the right we would have the settling tank effluent liquid. On the far left is what would be coming off the bottom of the low flow. And then in the middle, we're mixing with, if you can envision, 4 parts of the low flow effluent mixed with 1 part of the septic tank effluent. We would have this fairly dilute effluent in the recirc tank. So that effluent then is dosed to the top of the low flow filter, pressurizes the coil. Liquid will then trickle down through the media and is collected in the underdrain, and then flows back into the recirc tank. Now this will continue to happen until the level in the recirc tank rises due to effluent being discharged from the resettling tank into the mixing tank, and a splitter valve or foot valve will then rise and close off the opening, precluding water from being able to come back into the recirculating tank, and consequently then the water then flows forward into the clarifier and discharge tank, and from here it's dosed to the next sequence, which is the Oscar itself. The Oscar is an acronym that stands for an on-site sand coil area reuse. It's just a simple arrangement of subsurface drip tubing. Here we're showing a 50 gallon a day coil on a layer of sand. This sand would be encased inside of either a 30 mil membrane liner or in a large concrete vault. And then the top of this would have been covered with another 6 inches of sand. When the system is completed, you'll see the wetting pattern that's produced with the coils. And then about a year later, when we plant grass, which is the preferred cover material over the top of the Oscar, you can see the amount of green striping or green patches that accumulate, indicating a large uptake of nitrogen. And just some other examples of what the flow of nitrogen rich water being taken up by the grass here on this individual single family residence. You can see where it's not flowing and areas where it is. And again, this is just sand on top of the Oscar coils being dosed with low flow effluent. And then this will give you an indication of the quality of effluent being dosed or flowing out of the Oscar. Very clean. Again, turbidity is down below 2, usually around 1.5 NTUs. Now, the treatment train we've had tested through NSF, the National Sanitation Foundation, under 3 separate tests. We tested the Oscar with just septic tank effluent alone. We tested the low flow unit, and we pulled samples both before and after UV disinfection light. And then we had another test where we combined the Oscar and the low flow to come up with the current arrangement we're using now. So first, I'd like to talk a little bit about the Oscar itself being dosed with septic tank effluent. The basic arrangement or design criteria for the Oscars will have 2 subsurface drip emitters per square foot. The overall loading rate to the sand is 2 gallons per square foot per day. And in this particular case, we're using only a 6-inch deep layer of C33 sand. We would be proposing 12 inches in a reclaimed application. And the settling tank had a 2-day retention time. The end results are 6 months averages for CBOD and TSS were 2 milligrams per liter. Influence both for BOD and TSS are about 240 milligrams per liter. The 6-month average for fecal coliform, and I'm using fecal and total coliform interchangeably here, was about 755 colony forming units. And our turbidity, which we'd actually done on a different test, ranged about 1 to 2 NTUs. The second test we ran was just with the low flow, and then we tested for fecal coliform before and after UV disinfection. The low flow itself was dosed at 25 gallons per square foot per day. We had roughly 800 emitters in the low flow, which gave us about 40 emitters per square foot. It's a very tight pattern, distribution pattern. The test results from that arrangement were CBOD and TSS of 5 and 9, still under 10. Very similar influent characteristics from the previous test. Our highest monthly average for fecal coliform colony forming units per 100 mil was under 75,000. Post UV for the average for the entire 6 months was less than 20 colony forming units. And when you looked at the monthly averages pre and post disinfection, we had a conservative 3 log removal of fecal coliform. And in this test, our turbidities were under 5, average between 4 and 5 someplace. Now, a visual of the difference of what was coming out of our settling tank and then what came out the bottom of the low flow is illustrated here with these 2 containers, 2 beakers. So our third test, where we combined the Oscar and the low flow, we have 3 of our 4 components for Class A system. Again, settling, the recirc or oxidation, and then the filtration through the Oscar unit itself. What we found is we had, again, 2 milligrams per liter CBOD TSS. Our fecal coliform we averaged for the 6-month test at 27 colony forming units. We did not actually have a UV unit on this one, but if we followed the same assumption of getting 3 log removal, we're easily less than 1 or less than 2 total colony forming units. And again, our turbidities at about 1. We've come up with a module, and of course this can vary, but to just give you an example of what a building block for a Class A reclaim system would be, we'd use a 16,000 gallon a day module. The settling tank criteria would be 2 times the design flow, so about 32,000 gallon tank. A recirc tank is about 1 day's design flow at about 16,000 gallons. The low flow filter, we would propose using 1 basin for every 500 gallons of design flow, so we would need 32 basins. And then the clarifier discharge tank is about 60% of our design flow, so at about 10,000 gallons. Our Oscar coils, we would use the 100 gallon or a gallon a day version. We'd need 156 Oscar coils contained within a holding vessel. And then at least 1 UV light. We might want to use 2 for redundancy to make sure we always had that proper kill at the end of the process. What that would look like is we could use a 50,000 gallon 12-foot diameter fiberglass tank that was split up in about a two-third, one-third split. So we had about 35,000 on one side and about 15,000 on the other. We'd have a series of 4 pumps that would alternate back and forth between 2 groups, and we could dose 4 zones or groupings of low flow basins. That effluent would then be discharged into our discharge tank. And from here, we'd have 2 pumps that would then alternate dosing through 4 groupings of 156 Oscar coils. And again, we run that all through a UV lamp. And this tank could be a large tank servicing multiples of these 16,000 gallon a day units, or an individual tank as we're showing here. Electrical power, again, we've got 4 pumps in the recirc tank. And again, there's 2 pumps that will operate and duplex back and forth between each other. These are only half horse motors, 110 volts. The Oscars would have 2 pumps that duplex back and forth. And then the pumps, again, are still half horse motors. The UV light would run at about 1.4 kilowatts. So looking at long-term electrical costs, assuming about 10 cents a kilowatt hour, I just assume in the recirc tank that we're going to have 2 pumps for the most part running continuously. Again, they're alternating back and forth. That's going to run about $166 a month. The Oscar coils pumps run for a little bit less, about $30 a month. The UV light running continuously would be about $100 a month. Applications where we would see this being used is in large commercial buildings in an urban setting. They could be apartments or large condo buildings. A municipality, say of up to 500,000 gallons per day, or we could break this up into satellite facilities in a large metropolitan area where an entire subdivision or neighborhood is serviced by a satellite system, where we could treat and then reuse the water closer to where it was generated, as opposed to bringing it all back to a central facility, or then bringing it back to an outer lying area. Or it could be centralized as well. Also, being able to retrofit existing systems. This is a very light footprint. It's very easy install, and again, we just need settled raw sewage as the inflow, so there's not a whole lot of precursor that's needed to retrofit. And then another concept would be water mining. And what I mean by that term is, if we've got say a golf course with a sewer line that's nearby, the golf course, as in this example, could siphon off a given amount of sewage every day, process that into Class A, and then use that on the golf course. If there ever was an upset with that particular type of application, then the default would be to just pump the water right back into the sewer line, and no harm. Most of the time, though, we'd be able to reclaim a vast majority of the water. Benefits of this arrangement is low power costs. It's very easy to expand or add treatment capability if need be. What's very interesting is in the filtration step of our 4-step process, we don't need to add any alum or any other type of coagulant to the process, and neither then do we need to have another process to filter out that coagulant. There's no chlorine to add because we're using UV for disinfection, and there's just very few moving parts. You have a couple of half-horse motor pumps that can be easily replaced and or fixed there on site. Thanks for watching, and hope you found this informational.